PermAlert cable and connector testing procedures. The installation test should be run after the installation of each connector and the continuity test after the installation of both connectors on a section of cable. All of the testing will be done using a multimeter set to the resistance or ohms setting. The symbol for resistance on most multimeters is omega, or the upside down horseshoe symbol. There are three types of multimeters. The first is the analog multimeter, which I don't have and haven't used for 20 years. The second is a standard multimeter, and the third is an auto-ranging multimeter. To set up a standard multimeter or an analog multimeter, set the resistance to the 200 ohm range. When using an auto-ranging multimeter, set it to the ohms position. Both of the meters are now reading an open circuit. As you can see with the two example meters, an open circuit can be displayed differently. For this video, we will be using the auto-ranging multimeter. The first test we are going to do is the insulation test. First step is to make sure both ends of the cable are open. For example, check if the connector is shorted in a metal junction box or shorted against the connector from another cable. Or, if only one of the connectors is installed, that the braid wire on the other end of the cable is not touching the center conductor. Remember that the insulation test should be run after the installation of each connector. With the next step, we will thread back the coupling ring enough so that we can hook up one of the multimeter probe leads to the plug body. Then, take the other multimeter probe lead and connect it to the pin of the plug body. With the probe leads hooked up, the multimeter must continue to read an open circuit. Next, flex the connector. During the flexing process, the open circuit reading must remain stable. If it does, you pass the insulation test. If you get a resistance reading of less than 100 ohms, you probably have a short inside the connector you are testing, or the cable is crushed somewhere between the connectors. If you get a fluctuating reading when you are flexing the connector, you have an intermittent short in that connector. In either case, the connector must be replaced. Next, we are going to do the continuity test. In order to do a continuity test, the connectors must be installed on both sides of the cable. Go to the far side of the cable that is being tested and install a jumper wire from the center conductor to the outside part of the plug body. Then, hook one of the multimeter probe leads to the plug body and the other to the pin. For a good continuity reading, you should read approximately 10 ohms per 1,000 feet of cable. For this cable, we are reading less than 1 ohm. If, when we flex the cable at the connectors on both sides of the cable, the reading stays stable, the connector passes the continuity test. If the reading is an open circuit, or when you flex the cable at the connectors, the reading is not stable, then you have one or more of the following problems. One of the probe leads or one of the jumper leads came off the connector, or the center pin is improperly soldered or not soldered at all, or if the center pin is crimped, the wire flow was left out, or the pin was not crimped. Or the outer or shield crimp furl was not crimped. Or the cable is cut or broken somewhere between the connectors. If you get a higher than expected resistance reading, which would be anything over the approximately 10 ohms per 1,000 feet, then the outer braid was improperly sanded or not sanded at all under the outer or shield crimp furl. Or the braid wire between the connectors was damaged. If you do not get a stable low resistance reading, then the cable or one or both of the connectors will have to be replaced.